Hello and welcome to the next mini episode of Poor Man's Electronics Bench. While I've been away doing other stuff for winter and playing around with some boat updating and repair, I figure I would look into something that's a kind of a topic. Seeing that Tony is going over his LC102 and he was mentioning about the brick power adapter that goes along with it. I thought I'd take a look into mine and see if anything needed to be updated. So this is basically the culprit here. And I figure it's worth looking into because this is one thing that is usually going to be plugged in full time and putting out power. The 102 unit might not be getting full power to it all the time, but this guy is going to, since it's brick like it is probably going to be plugged into the wall and left plugged in and powered, and people are just going to forget about it. And we're going to see if anything needs to be updated inside of this guy. Let's take a easy enough to access, and I'm guessing it's not potted because it does have screws. That and the fact I'm guilty of taking a sneak peek into it. So yeah, this is the contents. It is a very basic linear power supply, unregulated. Just the 3 diodes and a resistor. I'm not sure if this other one, I'm not sure if this is a Zener or not, but I don't really care. I know the power supply is basically functioning properly. It's just probably in the need of update. Oh, there's 2 diodes, so it could be a full wave bridge configuration. But like I said, the only thing that might be aged and in need of repair is the capacitor. So we're going to take a quick look at that one. And this is definitely an off-brand, a Fuyin. The 105C capacitor, which is curious, and it says vent. It might have a side vent on it. Hard to tell. Luckily, it didn't vent, and we'll try to prevent it from doing that by just updating it. And it looks like the value on here is going to be a 4700 micro at 35 volts. And I'm not really going to worry about anything to do with its possible longevity. I am just going to go through the process of updating it. So I'm going to take some measurements on it. Got a little pair of calipers here, calibrated to millimeters. And for a diameter, we have to probably keep it under a max of 18 millimeters in diameter. Height-wise, the capacitor is about 40. Then the pitch on the pins, that's a little, looks to be about 6, give or take. So we're looking for a 18 by 40. I'll write that down on the cap just so I don't forget. I got an 18D 40H and the 6P. So now I'm going to go through the process of looking on my favorite site to get parts from, Digikey, and see what we can do here. So now I've gotten to my Digikey electronics page, and I am going to go through the process of looking up a capacitor to use to replace the existing capacitor in the Sencore brick. So first off, we're going to check the in-stock box because we don't want to wait for things, and we also want to exclude marketplace products because they do offer ordering items directly from a manufacturer, but unfortunately that adds cost to it because it's a separate shipping fee direct from the manufacturer to you, and it also usually adds some time. So we're going to hit those two and hit apply. And after that, we're going to select some values that we do know about. We're going to go, we've got a 4700 microfarad, and we're going to go upscale a little bit. You can say we can go up to a 5600 and probably not stress anything. And we're going to do the same thing for the voltage a little bit. We have a 35 volt rated capacitor, but I'm also going to select up to a 50. Granted, I may not pick something with a higher voltage, or it may not be the best choice. But we're just going to add this to the selections, and this website can be frustrating sometimes because it'll sit there and spin and lock up and not know what it's doing for a while. Okay, we got that. We got our capacitance values and our voltage rating, so now we want to go pick our physical size on things. We know that we need, for these capacitors, it's because our smallest lead size is going to be 7.5 mil, and we know we can go up to 18, so we'll pick that. And then as far as the height, we do have a little fudge room because the capacitor is about 3 or 4 millimeters shorter than the transformer. There's nothing inside the housing that prevents a little bit larger capacitor from going in there, so we're going to select everything from 31 to about a 42 millimeter in height. And that selects us down to 28 capacitors for results. And the next thing I'm going to look at is the ripple current reading at low frequency. Choosing something that has a higher ripple current rating is inherently going to give it a longer lifespan in an application for a unfiltered or for an unregulated DC power supply like this. It's going to let it handle those 120 hertz pulses better from the full wave bridge. In order to select the capacitors in order of ripple current, you have to go over to the ripple current. You've got a low frequency and high frequency column. You want to take the low frequency and hit the down arrow. Clicking the down arrow will sort things and index them in a highest ripple current at the top in descending order. So now if you look at ripple current at low frequency, our highest ripple current is a 5.193 at 120. 4.76 amps is the next one. And we're going to go over and see what the damage is going to be to our wallet. So our top two contenders are both United Chemicon capacitors. They're both in stock. The most expensive one with the highest ripple current is $6.9 per one each. Second one is $4.97. They're both 4700 micros at 35 volts. The ESR equivalent is rated on here at 100 kilohertz. And if you notice the temperature and hour rating, this is a 3000 hours at 135 degrees C. So these are automotive application capacitors, but they will work just fine in a situation like this. Our next one down here, if you notice, it's a 5000 hours at 125 degrees C. It's also an automotive. And then after that, we're getting down to general purpose. And I'm not really going to worry about the fact that I'm using automotive capacitors in a non-automotive application. Some people might frown upon that, but in this instance, they should work fine. And seeing that the hour and the temperature reading is as high as possible, and there's really no cooling inside of that brick at all. If it sits plugged in and develops heat, I want something that's going to handle heat fairly well. So out of the two, I think I'm going to pick number 2. It's about $2 cheaper. Double check the parameters for the height and everything. We've got our 7.5 millimeter lead pitch, 18 millimeter diameter, and this one is actually fairly shorter at a 31.5 millimeter height versus 37 or the original 40, so it should fit just fine inside the unit. So I'm going to take a quantity of one of these add it to my next order, but what I'm going to do is put it in a list or a bill of material first, and I'm just going to punch in a customer reference. LC102 PA251 PSC1. And when you order it, they will print that information on the bag, so if you get a jumbled order of parts with items, and then I'm going to do a new list of a LC102 PA251 PS. So now I can click that, I can go to my list, select that item and add it to a cart. So that's the gist of how I chose to pick capacitors. I could have went to a more common general purpose for $1.50 cheaper for a Digikey, but I want to try to get the highest hour rating capacitor I can in this guy. It'll fit in service well enough. And just to throw a little more information at things, I went to the data sheet on a particular capacitor I chose just to check out some pertinent information on them. And this is the Nippon Chemicon GPD series. It is a downsized and high ripple current version of the GPA, which I believe was the top selection on the choices. That was also about 15-20%. No, it was about 15% higher in cost. And it says for automobile modules and other high temperature applications. And in this case, we are interested in the high temperature applications part. Now, I'm not saying that that brick is going to get up to within 125 degrees C on the inside, but it does have a chance of having an elevated temperature over its lifespan if it's plugged in. And between the higher temperature ratings, the higher hour rating, and the higher ripple current, it will have a good choice or a good chance of maintaining its value and performance over its lifetime. And seeing that the other component has got to be at least 30 plus years old and may have been plugged in for a long period of time into a wall, I can't prove or deny that, but it's still something that I feel should be replaced so I don't have a problem going forward. And just looking at some of the other specifications, it has all the tolerance, the rated voltage ranges, dissipation factor, low temperature, the endurance ratings for things at time and temperature, and going over some of the dimensions and other features on the capacitor. A good data sheet will have the location of any venting feature that's built into the capacitor. In this particular case, the vent is built into the top of the capacitor. Some of them are built into the top, some are built into a side, and some are built into the bottom. Then it's nice to pay attention to this, especially the ones on the bottom, because if you do have a capacitor that is designed to vent in the bottom part of it, you probably want to hold it off the printed circuit board a little bit to allow any evacuation of contents, minor or catastrophic, that may occur over its lifetime of use, where it might just feel that it has to quit working. And another thing here is the F dimensions, the lead spacing. On an 18 millimeter diameter capacitor, it is rated with a lead diameter of 0.8 millimeters and a lead spacing dimension of 7.5 millimeters plus or minus 1, so that could be anywhere from 7 to 8 millimeters. This possibly will be a little wider than the existing capacitor that's in there if I find that I can't do a good job of dog-legging the leads, which I should be able to dog-leg it and hold it off the board a little bit since it is a shorter capacitor. Shouldn't have a problem with that. If not, I'd consider drilling some wider, either elongating the holes that are in the board or drilling some alternate mounting holes in the proper mounting configuration. Well, that's just a little more information to look at about ordering these particular capacitors, or any capacitors in general. If you're going to be doing replacements, you just want to try to match the parameters and the specifications for the purposes intended for your install. Well, I just want to go and get a capacitor that's going to fit and work well over time, something with a good high hour and high temperature rating. Should have a long life enclosed on the unit here. And just going over things, you want to make a quick inspection of everything else. The solder joints all look pretty suitable in this guy. Like I said, this is working fine. There's no other components affected. The only other thing you might want to do is double check and tighten. This one's got a little looseness to it. I'll probably tighten it and then put a little bit of green Loctite on the fastener itself after I double check and secure it, just so it doesn't back out. It's grounded to the transformer core and then through the hardware, which is interesting, but seems to be a working situation. So that's going to be it for just a quick review of working on the power brick for the LC102. And I hope that this content is something that gives you some information if anybody has one and is interested in updating your capacitor in here and just doing an inspection in general. And I thank you for viewing it. And if you like the content, please feel free to give it a like. And if you would like to see more content like this, please feel free to subscribe to the channel. And thank you, and I hope to see you back on the channel soon. This content is available on YouTube and Odyssey.com. If you enjoyed this, please like and subscribe. Hope you return soon.